Thank you. Unfortunately, Prasenjit is not well today, so he's not been able to join us, so it's just me. Before I start, I think there's going to be a lot of data in this presentation, but I thought maybe I'll try and gather some more. How many people in the organization are a majority of their, how many people here have a majority of their developers in their organization using AI assistants or AI agents? Okay, so I reckon 3/4, maybe more. So yeah, let's go. Okay. So yeah, I'm Tom Howlett, work on product at Sonar. Very quickly, how many people use Sonar Cube here in the organizations? Okay. Cool. Yeah, so I'm going to just dive straight into it. AI is obviously transforming the way we develop software and the code. There's lots of stats, they're changing all the time. A few we've picked out here are 84% from the 2025 Stack Overflow service planning to use AI development in their process. Cursor, kind of one of the new kids on the block in IDEs, is accepting, their agents are writing almost 1 billion lines of code a day, which seems incredible. And Gartner is saying 90% of enterprise software engineers will be using code assistants by 2028. So, I mean, it's obviously having a huge impact. So we really need to think about the future and where that's going. So I think we need to make some assumptions going forward, as Mohammed kind of said, how is this going to change things? I think we can assume that AI will probably write all code at some point in time. And what we're already seeing is the sheer quantity of that code is increasing. We're seeing far more code being written. Unfortunately, that means we've got far more code to maintain. And that code isn't, because it's not necessarily written by developers, it may not be as easy to maintain by developers as humanly written code. I think the bottom line here is that developers still remain accountable for the code. And that's the fundamental challenge we're faced with at the moment. And that's increasing the work of the developer. So rather than requiring less developers at the moment, we're requiring more developers to verify the amount of code that's being generated. So the huge promise, and we see it when if anyone's tried writing code with AI, it's incredibly productive. You can knock up applications in minutes, if not hours. The promise is enormous. The reality that we're seeing in organizations is a little bit different. And one of the reasons for that is because that code needs to be verified. That code needs to be checked. We need to make sure it's secure, reliable, and maintainable. And that really slows things down. And there's a lot of different surveys talking about the outcome of using AI and whether it is actually more productive or less productive at the moment. I think that's changing all the time, and it's very contextual. But the reality is this kind of bottleneck of verification is the biggest challenge we face at the moment. And I think at Sonar, it's one of the things we've always kind of looked into is the verification of code. So we see we see this as an area we can really help in. So if we're going to help and we're going to catch the issues, we need to understand what the LLMs are actually doing. So we've kind of got a team at Sonar that's basically analyzing the LLMs, or basically the output of the LLMs. They've set up a framework where we can put an LLM to work generating, I think it's like 4,500 different tasks, code generation tasks. And then each model generates the code to do that. We measure the outcome, whether they succeeded in the tasks, and then we measure the quality of the code. So we measure the code for reliability, maintainability, and security. And what you're going to see over the next few slides is the kind of results of those studies. This study is continually being updated as new models come through. So the latest iteration has got GPT-5 in, which is a very interesting model. So I'm going to dive into that. I'll just kind of start with the key findings, and then we'll kind of dig in and really kind of understand what's going on. So as you would expect, all the models generate a lot of issues. It's consistent. They were trained by human developers. The code they were generated in has issues. They then generate those issues themselves. The new bigger and newer models aren't necessarily better in terms of quality, although they're obviously getting better in terms of the features that they can deliver. In some tasks, small models can be better. And then we've got these new kind of reasoning levels coming in, and they're having some very interesting impacts on the quality, which I'll dig into. So here's a kind of here's a bit of a history, I guess. We're sort of starting in some very small models like OpenCoder, Llama, and then kind of building up to the modern ones. Obviously, Claude had a huge impact, really outperforming GPT a lot, and now we've got GPT-5. Now, this graph is basically functional performance, so these are the percentage of tasks that are successfully being completed by the models. And on the left, we've got cognitive complexity. Cognitive complexity is basically a complexity measure that Sonar use. If you use our products, you'll kind of see it there. It's all over the place. But it's really how easy this code is to understand, how complex it is, how difficult it's likely to be to maintain from a complexity perspective. And we can see a fairly linear rise. As the kind of functional performance goes up, the complexity comes up. The size of the bubbles are the amount of code that was generated for these 4,500 tasks. So we can see that's also fairly limited. We go from 200,000 to 371,000 lines of code. And then GPT comes along and kind of blows that out the water and puts 500,000 lines of code in there, which we'll kind of get into why, but it has I think it has a really interesting, it makes some interesting assumptions about the future of what AI code is going to look like. So let's dig in a little bit more here. This slide isn't great because it's quite fine detail there. I'm going to have to peer this way. So bugs and vulnerabilities. They're generally muchness, right? So this is, as the code goes up, obviously the amount of bugs and vulnerabilities go up. We are seeing with the modern models that the vulnerabilities are dropping. So this is the amount of vulnerabilities are dropping, which is a good thing. So I think we should be encouraged by that. Bugs are kind of still going up. The code smells, which are what we call one of our terms for maintainability issues, they're just going up linearly by the size of code. And yes, so we can kind of see that across here. The complexity obviously going up fairly linearly. If we normalize that, whoops, I just messed up here. Okay. We'd start looking at issue density. So this is the amount of issues you see per 1,000 lines of code generally. We can see that on the overall issues, they're fairly linear. That's kind of fine. They're fairly flat. Code smells fairly flat. We can see Claude, and I think if anyone's used Claude for coding, it is a bit better. There's definitely a drop there. I think we saw Claude's in a nice place. I must say most of our developers use Claude internally. The vulnerabilities is again sort of showing the similar pattern where we're getting much better on vulnerabilities and bugs kind of not so much yet, but we'll get there. This is looking at most critical issues. So these are our kind of blocker and high severity issues. And again, we're really seeing that GPT-5 is really starting to catch these more critical issues. I'm guessing I don't know if it's part of the reasoning or something in the training, but it is catching some of the more critical issues. I guess the model makers are training a bit more to avoid these problems. So yeah, we are seeing some improvements there. However, it doesn't tell the whole story. So what we're seeing is a changing nature of the issues we're catching. So this is around vulnerabilities. Now, on coding vulnerabilities, injection flaws are probably the most kind of common and most understood. So SQL injection or different types of injection. Now, it seems that on GPT-5, they've almost been removed, which is really impressive because these are difficult issues to find. You know, they tend to have a path. You have to follow a data flow throughout a path. I guess there's a question of quite how complex that path is and how much it can kind of follow the path, etc. and we don't capture all of these. We have to be honest with it. So there may still be some really complex ones that we can't find either. But it's certainly a big improvement there, and we're certainly finding a lot less. But there's a really weird turnaround that whilst the number of injection flaws has dropped, we've got I/O error handling. Now, this is a fairly critical security issue. If you're kind of reading or writing data and not handling any errors in that, you can have data inconsistencies, you can have all sorts of problems going on there. And it seems all of a sudden that GPT-5 seems to be messing that up. We're not quite sure why at the moment. But yeah, it's a really interesting, I think the thing to learn from this is that each model is different and potentially has different patterns of vulnerabilities, and we're kind of calling that they have their own personality in a sense that perhaps you need to understand and learn. We have a similar kind of story with bugs. So, I mean, a lot of bugs are control flow mistakes, right? So a switch statement or an if that isn't quite right, it probably has some dead code somewhere that never gets hit. And we capture a lot of those. And we can see, Claude seemed to really peak. Claude 4 did great on these now, really dropping them out. And GPT-5 still doesn't do as well. But GPT-5 is definitely a big improvement over 4, and in many areas is now beating Claude. However, there's a real outlier here. I don't know if you can see this kind of 20 here, so the concurrency and threading issues. So all of a sudden, we're finding more concurrency and threading issues in GPT-5. And I think that has a big implication. I think what we're seeing is that GPT-5 is creating this more complex code. It's probably using more multi-threading, more kind of advanced techniques, and therefore there's potentially sort of new bugs that are emerging that we weren't seeing before. And I think this is something we've really got to be mindful of. So yeah, okay. Obviously, where do these bugs come from? Obviously, traditionally we understand that they're trained on flawed code in the first place, so they will do. But I think it's interesting to see what we're seeing from the reasoning models like GPT-5, that they seem to be overcoming some of that in a sense. And I think through reasoning, they're actually starting to kind of fix some of these bugs and maybe jump into conclusions there. But yeah, we're seeing this kind of the risk shifting across to kind of more complex, more hard to detect bugs and away from the more basic bugs. However, on the maintainability side, we're not seeing an improvement. So we've got this problem where we've got this bloat of code, we're generating more and more complex code. Yes, there might be less issues in it, but because it's more complex, because it's harder to maintain, they are going to be harder to spot as well. So we've kind of got this kind of swings and roundabouts going on here. And it's not so, the newer models aren't necessarily going to be better in terms of long-term maintainability and being able to find issues within that code. So this is kind of Sonar's approach to this. We've heard a bit about trust then verify being the kind of the previous software 1.0 from Mohammed this morning. The way we describe it is vibe then verify, which is kind of obviously playing on the vibe coding piece. So I think we're talking about all AI assistants really here. So yeah, I mean, I think the thing we've got to do is verify the code carefully. It's too much for humans to do alone, right? That's really going to slow us down. We need to create tooling that's going to help do that. I don't think it's necessarily a good idea to use AI to verify AI. There's some certain challenges there, and we don't. Our analysis doesn't use AI. We use AI for code generation, for fixes around this. But we stick to very deterministic checks for the checking to make sure that we're finding things. And I think this tooling is going to become necessary for developers to be checking the code and finding these issues as early as possible. We've kind of moved to trying to make the developer's life easier by providing fixes for issues. I think traditionally people that have used Sonar for a long time know, well, it's great, but what do I do with all these issues now? Well, at least now we've got AI to fix that. And so we've got a code fix, which will make suggestions to the developers, and we've got an agent now about to be released, which will fix them autonomously as well. And then obviously we then re-verify the code. So so we're seeing, I think this is going to be a key part of coding in the future. I think the other thing that's really changing is the interface. So traditionally, SonarQube, if you've used it, it's generally used in the pull request, right? Before a commit is merged, Sonar will do a check and find the issues. The problem with that is you've then got to go back. The developer's got to pick up the issues. They've got to make some changes. They've got to re-update the PR. There's a kind of fairly slow cycle to that. We've got an IDE plugin which finds most of the issues as you're coding, kind of like a spell check kind of piece. So we really encourage developers to be using that. Now it's not just working with human developers, it's working with the AI. So we're integrating with the new kids on the block like Cursor and Windsurf, so that their agents that are running in those IDEs are fixing the Sonar issues as they're found. We've also developed an MCP server so that the agent can just contact Sonar straight away to verify its code to help it when it's fixing issues. So our kind of interface is moving from just interacting with human developers to actually interacting with the AI agents as well. And I think as we kind of develop that and things stabilize a bit, we should be in a situation where the code that makes it into the PR is clean, because it's been updated by the agents and the AI assistants as it was coded. So hopefully life will get a bit better on that thing. So I see a real positive to this in productivity as well. Okay. If you want to see more of these reports, and I guess you can get updates on these reports as well, here's a kind of QR code to read more in depth, and there's much more in there if you really want to understand. Cool. I think I probably rushed through on time, as I always do. There's going to be time for questions.
There's definitely a lot of questions.
Okay.
The first one, on the task comparisons, have you tested how humans compare?
That's a really good question. And I was thinking about this as I was preparing this talk. We haven't done yet. I mean, we do have statistics on the overall issues we see in repositories. Obviously, we take these statistics out. I think I've not done a comparison, and it's on these actual coding tasks. I guess we would have to get some humans to generate the coding task to get a like for like. Every kind of project is different. Every coding standards vary, complexities vary. So it's very hard to compare. But to put some developers on those 4,500 tasks and see how they compare would be a super interesting thing. I'm not sure who's going to do it. But, yeah.
I think you just answered that last one. Is this study openly available?
Yes.
See if we can get that QR code back on screen in a sec.
Yeah, so that QR code is a kind of report that's a fairly easy read. There is also kind of scientific papers as well with more technical details if you want to see how we're doing it.
The classic existential question, shouldn't we fight the assumption that AI will write all code? We value craftsmanship. I think human quality programming will be the superpower in an AI future.
It's a really interesting one. I think I would love to say that that human crafted code will win, and I think even the most purist of craftsmen, I think, can probably still benefit from AI. I think part of the thing that I find it's so much more productive with coding is that I'm not kind of going off and reading documentation. I'm not going off to Stack Overflow. If I want to understand how an API is used, I can quickly get that. The problem is that may not always be correct, right? And this is the tough bit, that it makes you so much more faster in real terms in programming, but you've got to be super careful because you can't trust it in the same way as you could reading some documentation about an API that you aren't necessarily familiar with. I think real craftsmen probably don't overuse AI is probably the thing, and whether the agents get to craftsman level coding in the future will be really interesting to see, I think. Yeah.
Okay, here we don't see any Gemini models in comparison. Does it mean it's inferior to those models included for comparison?
Good question. I don't know why we haven't included Gemini at the moment. I don't see why we shouldn't. I can look that up. If you perhaps want to come and see me at the stand, I'll find out and give you an answer to that question.
Good stuff. How does this work when you need to meet 4 eyes principles? Should agents commit directly, Or is it a human accepting the changes and committing under their name?
I think it's going to be up to you.
Yeah.
And I think the general standard model at the moment is the developer doing the first set of verification and then a second step after that, which I think really makes sense and kind of always has with coding. It's always been really more productive. But whether we just get to the point where the agent is committing and a single person is verifying, I don't know. Yeah, I'm not sure. Quite ready for that yet.
Stuff. One from Rob. LLMs do better the more detail you can be with prompts. How do you go about building a general tool that performs as well as something bespoke to each company?
Oof, that's a hard question. Building a general tool that performs. Okay. I'm really not sure. I think come and discuss that with me, Rob.
See me after.
I think we should talk about that. Yeah.
One on the methodology here, how much prompting was down to instruct evasion of common bugs and security flaws? For example, prompting never hard code credentials.
I think this is something that we're seeing in the configuration of in things like Cursor, where you can kind of put guidelines in. We're kind of working on things at the moment where we can help craft those guidelines that will go into the initial prompt that is used, and I think that can really help. It's probably not going to catch everything. There's still going to be a job for verification, but yeah, I think there's a lot that can be done with prompting here, and we're working on something at the moment where it actively kind of looks at projects, understands the big issues on that, and then makes sure that the prompt knows not to create those. So yeah, we're kind of experimenting with various techniques around this.
Any early insight into how Claude Sonnet 4.5 compares with 4 and GPT-5?
Yeah, I don't have, I'm afraid. But again, I can ping some of our R&D guys later, and we can maybe tell you on the stand.
Good stuff. Question here for Gemma. Would you consider the environmental impacts in future research?
Yeah, so it's an interesting one. We as part of our analysis, obviously, the main qualities we're looking for are reliability, maintainability, and security. But there's other things as well that we can analyze for in static analysis. So accessibility is one. And then sustainability is one that we've been looking at a lot. I don't know if you know, Sonar's based in Geneva, and there's lots of French people, and there's a big movement there for sustainability around code. So it's something we've been working with some organizations with to try to come up with some good principles. I think it's hard because there's only so much you can do statically, right? I can look at code and say, yeah, this is inefficient, this could be more efficient, but ultimately it's dynamic testing and actually where, how many million times a second is this function called, and therefore you should optimize it. It's very hard to always kind of work that out statically because you don't know how the application is going to be used. So I think soon you will see some sustainability reports coming into Sonar where we can identify some of these issues. And there are rules in there at the moment. If you look for rules that are tagged with speed, I think is generally the tag we use. They will kind of identify inefficient code, but it's always a controversial one because you don't know how that code is being used in runtime.
Next, do you have any stats on issues with Sonar MCP integrated feedback in code generation?
What kind of stats? I mean, like usage stats, how much it's being used, I guess. Maybe this is a come and chat to me afterwards.
Yeah.
I can see if I can get
Might be
some.
bug and issues with them.
Yeah. I mean, the MCP as it stands at the moment is running off a local analysis. And so we're not actually tracking anything there. We're working on a project at the moment where it will go back to your SonarQube server and do the analysis that way, at which point we'll be able to kind of track the bugs as they're being created as well. And that will give us much more data on what's happening at the MCP level, which will be interesting. Yeah.
So have you tested the assumption that AI shouldn't be involved in verification? What if future models don't generate errors or can identify them via prompting?
It's a really interesting one. I mean, it is quite possible, right, that AI can be helpful in verification. But AI is not accountable at the end of the day. So who's going to take responsibility? And I think this is the big kind of more philosophical question that we'll need to counter if we're going to go down that road.
And it's a bit similar. What approaches can you recommend to shift left the verification instead of vibe then verify?
Yeah, sure. So I mean, I guess so when you're working in AI, to use MCPs and use analyzers on the code. So if you're using something like Cursor or Windsurf, if you've got both our analysis, other analysis that you might want to use whilst you're coding, Cursor will go and fix those issues as you're coding. So a lot of the verification moves away there, a lot of the work, a lot of the issues you're going to find. But I don't think you ever want to completely shift left. We always want to have that verification step at some point. You know, even if it's just checking that the tools have done their job and what they did, etc., which it may get to in the future. And I think there'll be new types of tools. We're developing an architecture module to SonarQube at the moment, which will be out in the new year, which is going to do like architectural verification as well. So you can define a model, and it can start showing you, someone's just created a reference to something that shouldn't be referenced in this. And I think this is going to be a big part of it. And I think we saw that with the models, that maintainability is going to be the problem, not necessarily bugs and vulnerabilities in the future. And so architecture will be a big part of that.
Cool. Last one quickly, I think. Is the IDE available along with the Sonar Cloud license or SonarQube server license?
So the IDE is free. Anybody can use the IDE. You don't need a license at all. However, if you have a SonarQube Cloud or SonarQube server license, you can then connect the IDE up to your server or to cloud, and it will download the same analyzers that are being used in the server or cloud and give you the same results. It will use the same quality profiles and things like that. So it's free for use for anybody, but if you connect it to your server, you'll get better results, you get notifications, you get a deeper analysis, etc.
Good stuff. Well, look, thanks to Tom.
Cool. Thank you.
Thank you, mate.